Okay, what's up, very enthusiastic anatomy and physiology students? What we're going to go over today is the structures in the sarcomere. The sarcomere is the fundamental unit of muscle. So you break it down into its fine molecular structure. We're dealing with two proteins that interact called actin and myosin. Okay, and what we have down here then, the red part here is our actin, and this black bar in the middle is the myosin, and these of course are just for labeling. Okay, so we'll start with that then. Actin is our thin filament. Okay, so all of this in red is actin, and actually in a real actin filament they are tied together by this structure in the middle called the Z discs or the Z line. Okay, and that continues down further as you have more thin filaments that are all hooked together through the Z line. So the Z line is the anchoring part, the anchor for the thin filaments. Okay, the myosin then is the thick filament. It's this big guy in the middle. And this line down here is actually just for, it doesn't really have a line down the middle, but that is just to denote our M line or our middle line. So myosin is our thick filament, actin is our thin filament. The anchor for the actin filaments is called the Z line or the Z disc, and that is a real structure. The M line is just denoting the middle of the myosin filaments and is the middle of our sarcomere. So collectively, our sarcomere goes from the Z line of one actin filament to the Z line of another actin filament. So this large lambda here is our sarcomere. Okay? Then we have a few bands or zones that compromise the different areas within the sarcomere. Okay? The A band is the length of the myosin. So from one end of the myosin to the other is our A band. So that's this one right here. The H zone, okay, or the Hele zone, Hele for light, it's Latin for light, is the part of the myosin where there is no actin overlapping. So in the H zone we only have myosin, there's no actin at all. Okay, the I band then is the opposite of the H zone. It is the part where there is only actin. Okay, so the overlap of actin and myosin is not included in the I band. That's the actin molecules only. And the overlap is not included in the H zone. That's the myosin only. Okay? Those are the structures of the sarcomere. Now what happens is, on myosin are these globular heads. Okay? I'm going to just draw one here, and what happens is it attaches to or binds to the actin, and then the myosin heads contract. They use ATP to pull the actin towards the M line. Okay, and there's another myosin head on the other side. Well, there's lots of these myosin heads throughout the myosin, but they act in opposite directions on opposite ends. So this myosin head is pulling actin filament this way. This myosin head, or the myosin heads on this side, are pulling actin this way. So what's happening then is your Z lines are drawing closer together, which causes the H zone to shrink until, if it's fully contracted, the actin and myosin, or the actin filaments on each side will basically be almost touching. So the H zone will be almost nothing, practically disappeared. Okay? And I have a picture then of a contracted sarcomere. Okay, so in addition to that, your A bands, so there's an A band here, it's the myosin. You have another myosin over here, and basically you have these repeating segments. What happens when you have contraction is those Z lines are pulled closer together, and then the A bands are closer together. So this A band and this next A band over here, okay, are going to be closer together. Okay, the H zone is going to shrink, A bands will be closer together. The I bands shorten. So the distance, because these myosin filaments are closer together, there's going to be less area where there's only actin, and so that will shorten. Okay, the A bands will be closer together, but they'll remain the same length. Okay, so then what it looks like is basically this figure here. So this is an uncontracted. What we have here is pretty similar, different colors. So what we have here are the actin filaments are now closer together. See that there? The A band, which is the length of the myosin, it's still the same, but it's going to be closer to another A band on the other side. The Z lines are closer together, and the H zone has shrunken, and if it was fully contracted, it would be almost nothing. Okay, so those are the different parts in the sarcomere, and that's what happens during contraction.